All right, let's talk about RabbitMQ. You might not have heard of it, but it's kind of the secret engine, the central nervous system, powering so many of the resilient apps you use every single day. We're going to pull back the curtain and see exactly how this thing works.
So, have you ever been using an app and one little feature glitches out and then boom, the entire system just grinds to a halt? Yep, we've all been there. That right there is the classic spaghetti code trap. It's this absolute nightmare of cascading failures, where all the different services are so tangled up that one tiny hiccup can bring the whole house of cards crashing down. It's fragile, it's super frustrating, and honestly, it's the exact problem that modern software architecture is trying to fix.
So, how do we get out of that mess? Well, it's all about a big shift in architecture. If you look on the left, that's the old way, what we call direct coupling. Everything's hardwired together. So if one service fails, it takes others down with it. And trying to scale that, oh, it's a total nightmare. But now, look over on the right. That's the RabbitMQ way. We've introduced a middleman. And just like that, our services are decoupled. Failures are contained, and scaling is way more flexible. This right here is the game-changing shift. And that middleman has a name. It's called Message-Oriented Middleware, or MOM for short. Now, the best way to think about this is like a digital concierge. Seriously, picture a busy hotel. Instead of you having to run every single package up to every single room yourself, you just drop it off at the front desk, right? The concierge takes over. They handle all the logistics, routing, holding a package if the guest isn't there, making sure it gets delivered. You're completely free to go about your business. Well, that's exactly what this middleware does for all your different software applications. So in this whole system, there are really just three main players. First, you've got the producer. You can think of this as the manufacturer, the one creating the product, or in our case, the message. Then, in the middle, you have the broker. That's RabbitMQ itself, our logistics hub. It receives the message. And finally, you have the consumer. That's like the retailer who actually gets the message and does something useful with it. And the beautiful part? The producer and the consumer, they never even have to know each other exist. Okay, and this brings us to the most important point. If you remember one thing, make it this. It's a little counterintuitive at first, but it's the absolute core rule of RabbitMQ. Producers never, and I mean never, send a message directly to where it's going to be stored, which is called a queue. Instead, they send it to a routing hub called an exchange. This idea is called the Abstraction Principle, and I'm telling you, it's the secret sauce that makes RabbitMQ so incredibly powerful and flexible. You're probably asking, okay, so how does the producer tell the exchange where to send this thing? Well, it attaches a little something called a routing key. It's basically an address tag. But think of it less as a physical address and more like the producer just describing the message. So if it's a new order, the key might be something like orders.new. If it's a really bad error, maybe logs.error.critical. See? The producer is just defining what the message is about, not where it needs to end up. All right, now let's look at the other side of this puzzle. How does a queue, the storage box, know which messages it's supposed to grab from the exchange? Simple. It creates a link to the exchange that has a rule on it, kind of like a filter. And this filter is called the binding key. The binding key is basically the queue raising its hand and telling the exchange, hey, I'm interested in any messages that look like this. Okay, let's really nail this down because this is the absolute core logic of RabbitMQ. The routing key is the address on the package. The producer slaps it on there. The binding key, on the other hand, is the rule written on the mailbox. The consumer's queue sets that rule. So the producer is just shouting, hey, this message is about a new order. And way over on the other side, a consumer's queue is whispering, I'm interested in new orders. They never talk to each other. The exchange in the middle just does the matchmaking. It looks at the address on the package and finds the mailbox with the matching rule. That's it. So how does that matchmaking actually work? Well, it all comes down to the type of exchange you're using. And RabbitMQ gives us three really powerful options here. I like to call them the exchange triple threat. Let's break down how each one works. First up, we've got the direct exchange. This one is super straightforward, very precise. It only delivers a message to a queue if the binding key is an exact character-for-character match to the routing key. No wiggle room. So if the routing key on the message is PDF jobs, it's only going to queues that have a binding key of, you guessed it, PDF jobs. This is perfect for those targeted one-to-one jobs, like when you need to send a specific task to one dedicated PDF processing worker. Next up is the Fanout exchange, and this one is the total opposite of direct. It's a pure broadcast. It completely ignores the routing key, doesn't even look at it. It just takes the message and sends a copy to every single queue that's connected to it. It's like a megaphone.
This makes it absolutely perfect for those global, system-wide notifications, like a system maintenance alert that literally every service needs to see and see right now.
And last but definitely not least, we have the topic exchange. Now this one is arguably the most powerful and flexible of them all. Why? Because it doesn't look for an exact match. Instead, it uses wildcards to match patterns. And this, my friends, is what gives you true decoupling. A producer can send out a message with a very specific routing key, and different consumers can subscribe to all sorts of broad or narrow patterns of that data. The best part? You can add brand new services later on that listen for new patterns, and you never have to go back and touch the original producer code. It's incredibly future-proof. So how does this pattern matching work? The topic exchange has two special wildcards. First, there's the asterisk, or the star. This one matches exactly one word. So as you can see, if a queue has a binding key of logs.star.critical, it would match a message with a routing key like logs.db.critical. But it would not match logs.db.auth.critical because that's two words between the dots. Then you have the hash, or pound sign. This one's way more powerful. It matches 0 or more words. So check out this example. A binding of shipment.eu hash would catch a message with a routing key of shipment.eu.germany, and it would also catch shipment.eu. This gives you some seriously incredible filtering capabilities. Okay, beyond all this clever routing, RabbitMQ has another killer feature. It's a critical safety net. The queue itself acts as a buffer. Think of it like a circuit breaker. Picture this, it's Black Friday. Your website's ordering service is getting absolutely hammered with millions of requests a minute. Instead of sending all that traffic directly to your payment processor and crashing it, the orders just start piling up, nice and safe, inside a queue. Your processor can then just calmly work through that backlog at its own steady pace. The queue absorbs that massive spike and prevents a total system meltdown. It's a lifesaver. All right, let's switch gears and talk about efficiency, because this is really important. Under the hood, you have to understand the difference between a connection and a channel. A connection is the big one. It's the actual physical TCP network link between your app and the RabbitMQ server. And these things are heavy. They're expensive to create in terms of resources. They need network handshakes. They take up memory. So to get around that, RabbitMQ gives us channels. A channel is like a lightweight, virtual conversation that runs inside of that one single heavy connection. And the real magic here is a concept called multiplexing. What it means is instead of opening a new heavy resource-hogging TCP connection for every single little task, you just open one. Just one connection. And then over that single connection, you can run thousands of these lightweight channels. It's like having one big conference call line that can carry thousands of separate private conversations all at the same time. The payoff? You save a massive amount of network and CPU resources. And if you're building a high-performance system, this isn't just nice to have, it's absolutely critical.
Phew. Okay, I know that was a lot to take in, so let's boil it all down. Let's synthesize this into the absolute top takeaways you need to walk away with.
All right, here are the 4 big principles of RabbitMQ. Number 1, exchanges route, queues store. That separation, that abstraction is the whole game. Number 2, decoupling is your key to resilience. Letting messages wait in a buffer means your system can survive traffic spikes instead of just crashing. Number 3, use the right tool for the job. Use direct for specific tasks, Fanout for broadcasts, and topic when you need that awesome flexibility. And finally, number 4, efficiency matters. Always use lightweight channels over heavy connections whenever you can.
And that kind of brings us to a final provocative thought. We live in this era that's completely obsessed with instant everything. Speed, speed, speed. But what if the most powerful, the most underrated feature of a truly modern, resilient system isn't how fast it can go, but its strategic ability to wait? The ability to absorb pressure, to buffer work, and to keep the entire system from falling over, even when some parts are struggling to keep up. It's something to think about, isn't it?